Okay? Okay, we're in week 6 this week, and Thursday we're going to be going over a couple things. One's an Internet Security Lab using Internet Explorer, and then the other is WEP, or lack of security for WEP. We're going to look at that. So if you have a Wi-Fi, how many has a laptop with Wi-Fi or a mobile device with Wi-Fi? Okay, you can bring those on Thursday. I'll be setting up a access point in here, a rogue access point, and showing you how easy it is to, the web security is easily hacked and cracked, and we'll look at that software. One of the softwares you can download between now and then, if you wanted to play with, it's in the crack web folder. It's installer aircrack ng, and then the NetStumbler. NetStumbler is a Windows app. I'll show you what it looks like on my laptop here. What NetStumbler will do is it will go and grab your Wi-Fi NIC, and then it will scan for any Wi-Fi routers around your area. It'll give a list of MAC address, SSID, name, channel, and a whole bunch of other information, IP address. And this is all longitude, latitude. These can all be mapped out actually in a, pushed out to a map, and actually put plotters on maps as well. And so we'll talk about NetStumbler, and coupled with this installer aircrack, which is a software that is used to crack Wi-Fi network security. And then we'll talk about a technology you might have heard of, or a event you might have heard of called war driving. We'll talk about that on Thursday as well, which war driving is real popular amongst hackers, where they drive around and they will get plotted areas of IP addresses, weak WEP addresses, WPA addresses, and then plot them on a map, like a Google map, and then they'll actually give, for malicious purposes, try to go in and see how many they can hack. But in Los Angeles, well, not in Los Angeles, Vegas, once a year they have a convention where they actually give the community that they do this to in Vegas a report back to the businesses on the health of their Wi-Fi. And so it's kind of a competition. It's still a competition to see how many you can get in and connect to. The one thing they don't do in that competition is they do not try to, they sign a waiver saying they're not going to do any malicious whatever during this event. But then they come back with a report, a general report to the community saying here's the health of your Wi-Fi in Vegas. So they've done that for a number of years, and it's a war driving event. And so we'll talk about that and some other tools with war driving that are real popular. They've got them for mobile devices like iPhones, Droids as well. Some of you might have played with this. I saw some of you shake your head that you have heard of or used NetStumbler, so that's good. So if you have a laptop between now and Thursday, I would recommend downloading and running NetStumbler. It's just basically a scanner of Wi-Fi devices around your laptop is what it's going to basically do. I'll tell you what security it has on there. That's about all it does. Okay? And then these other tools like aircrack is actually used to grab onto that web connection and then to crack a web connection code. So we'll do that on Thursday. One of the things I'll show you on Thursday is how fast it is to crack a web connection, a web security key. Both a small one and a large one, both. We'll do kind of a medium, low security, medium security, high security web connection key, and show you how secure that is or unsecure that is. Also, we've got review questions as always, chapter quiz. Be thinking of, and this video we'll actually be watching at the end tonight. I'm going to kind of watch that one before we go. Be thinking of your research paper. I know none of you started it, but that's all right. I was in college not too long ago myself, and so I guess it has been a while now. So, but anyway, make sure be thinking of your research paper after spring break, which believe it or not is 2 weeks from now. We'll be doing a section on that Tuesday after spring break on helping you to get started, kind of outlining your research paper, how to do a presentation. And I did put in your lesson folder here, just a placeholder, which most students already know this, but I put it in there. Spring break coming up week of March 12th. So we've got this week and 2 more weeks after. Believe the next 2 weeks the labs will be doing one will be steganography, the art of hidden writing, and how to hide things within other things within files. And then I believe week 8 is going over looking at, well, let me look here. I just did it before class. Mine's blank. Portable GPG, which is basically email encryption. Show you how that works. This is an actual portable device you can run on your portable app. You can run on your portable USB device. So we'll be doing that right before break. Okay, tonight we're going to go over wireless security, since we're doing the lab on wireless for the most part on Thursday. It's been around a while. It's really come a long ways as far as security goes. It's got a ways to go. That's why you really don't see Wi-Fi as widespread as you might think it should be. The military is actually working on higher security. Right now we have, the highest we have now is a WPA2 enterprise version, which is actually pretty secure. But in the military, they still do not use Wi-Fi for communication because it's still vulnerable. Even with the WEP2, WPA2, not as vulnerable as WEP for sure, but so anytime we get anything new in Wi-Fi, just know it comes through military. It's went through them first. Now other technologies, maybe not so much, but Wi-Fi for sure. We get other technologies definitely through military, but Wi-Fi is one of the, anything security, anything generally is filtered, tested, and we usually as consumers have 2 to 3 or 4 levels below military grade security on purpose. Does that make sense? So in the consumer market, whatever we have now, which we'll talk about tonight, is 2 to 3 to 4 levels below what the military is testing. Does that make sense? And maybe in little ways using it in areas. Why do you think that is, you think? Yeah, anybody?
Well, if you give the people the technology, they can figure out how to hack into the military stuff.
Exactly. And so, yeah, some logic. The logic behind it is you don't want folks, you don't want people to have the same technology that the military has, because what's the sense in having military intelligence and things of that nature? And we've seen in past years that even then it's been breached. And so, you know, the need to know basis on this area for Wi-Fi is definitely very, very top secret. I did have a student 2 semesters ago that was a military specialist in Wi-Fi security that gave a presentation on what he could give anyway on some of the cool stuff coming out and what he had worked on in encryption. And the big thing they're working on, he did let out, is encryption. That's one component they're working on that will make WPA look like WEP, basically, when they're done. The encryption is just out of this world, what they're looking at to do. Randomization of encryption, the seed values being randomized, and so just crazy encryption, changing encryption bits to where you know they grab onto one encryption. It might be, say, 256, almost the highest encryption you can get, and then the next one go down to 128 or something. You know, so just a whole bunch of different technologies they're using trying to get wireless more secure. So IEEE, the Institute of Electrical and Electronics Engineers, Electrical and Electronic Engineers, IEEE, which we've talked about here, it also has IEEE as a student branch. If you go to IEEE.org, They actually have a student chapter here in the state of Illinois where you can join at no cost. There is some cost for such things as magazines, I believe, and some of the events that they have, but it's a pretty cool resource for students. You also get a full MSDN license if you're part of the IEEE.org as a member, as a student, which MSDN license by itself is $1,200. That's in and of itself. And so that's a pretty good deal. So you might check that website out and join. It won't cost anything to join IEEE.org for a student. And like I said, they do have like competitions, conferences all throughout the year in Chicago, Schaumburg area. But this organization is the most widely known and influential organization when it comes to wireless communication and networks. And they began in the early 80s, and their whole structure is to develop standards. Now, if you go to their website, you'll see a lot of standard documents, a lot of documentation, page after page after page after page after page after page of documentation on standards. And it first started out with a project called 802, and in 1990 they developed standards for WLANs, Wi-Fi LANs, and basically operated then only on a 1 to 2 million bits per second technology. 1997, they went up to an 802.11 standard, and some of the revisions since then is A, B, G, and then N is where we're currently at. When you go to the store to buy the newest Wi-Fi router, it's going to be the N technology. A lot of them are backwards compatible, called mixed mode with B and G. And we'll talk about that a little bit tonight, what that's all about. And so for most of you at home and business users that use it, Wi-Fi, you're going to be looking at more than likely the G and N Wi-Fi that you're using. Maybe a few Bs if they have really old devices that are out. So controlling access. This has been one of the limitations or one of the struggles, I guess, with Wi-Fi. You can control Wi-Fi access through MAC address filtering. And by restricting access to the access point, only those devices that are authorized can connect. So kind of like in a wired network, you can restrict wired units from also connecting to a network via MAC address filtering. You can do the same in the Wi-Fi world. But as we've learned in here, there are ways to spoof MAC addresses to get around that. But right out of the box, your routers will give you the ability to do MAC address filtering. The 802.11 standard does not specify how to implement it, but all these routers, Linksys, Cisco, have developed it and put it in there pretty much the same way. You have a list, basically, you can fill in like a text box of MAC addresses. And what I tell students to do, if you go home right now and you've had your router up for any period of time, you already have all your MAC addresses in your router. It already knows them all already, so you don't have to write them in. It knows them. So if you turn on your enabling MAC address filter, it'll automatically see all of them. And then you can basically just say, yes, I want this, no, I don't want that, or something like that. Or I just want all of these that are in here currently, and nothing else can come in. You can do that as well. Does not hurt speed. It does not, in fact, if anything, it might help, especially if you have end users trying to hit your Wi-Fi all the time. It could help a little bit on network traffic as far as your speed and throughput and bandwidth. And as I already mentioned, almost all Wi-Fi wireless AP vendors do implement this MAC address filtering. So basically you have your server, your network, whether it be home or business, and you have your access point connected to that wired network, and then laptops, mobile devices can then connect to that infrastructure through a Wi-Fi access point. So, you know, access points have really been great for networking professionals because it's a lot easier to install an access point in a remote building to connect to your network than to wire the whole building or wire the whole floor, whatever the case may be. And Wi-Fi networking and security is getting to the level where it can be done. It can definitely be done. and there's softwares out there, and we'll look at the security that's out there right now. But for most businesses, it's definitely feasible. So here's a Linksys router, which is probably the most popular that most of you have probably at home, that gives you the ability here to filter out MAC addresses, either enabling it, meaning blocking certain MAC addresses, or disable, meaning all MAC addresses are able to come on your device, and to try to connect. MAC address filtering usually implemented by permitting instead of preventing. So it's generally going to be a white list instead of a black list. You won't put a black list of MAC addresses, those that you don't want. You'll put a white list, and that's what white and black list means in networking. White list meaning only these can come in. Black list means those that cannot come in. So you put all the white list users that can come in. And then next is WEP. WEP is basically wired equivalent privacy, the very first security technology we had applied to Wi-Fi. And it was designed to ensure that only authorized parties could view wireless information. It used encryption, does use encryption to protect traffic. The 802.11 committee designed it to meet the following criteria: to be efficient, exportable, optional, self-synchronizing, and reasonably strong. At the time when it came out, that last one was such the case because there was not a lot of utilities out there, like we'll use Thursday, that could really crack them that fast. I mean, it took days to weeks to months sometimes. But as the technology was out there and the hackers began creating softwares, it went from hours from months to hours to days to minutes to seconds, if that makes sense. And so, yes, that statement was true when it first came out, and WEP is definitely better than nothing. Okay, it is better than nothing. It's kind of like, okay, I give WEP the equivalent of the door lock on a door versus WPA, maybe 10 padlocks on top of the door lock. So, WEP is better than nothing. And so I do tell students, because we'll talk about tonight, there are devices that maybe will only work, older devices will only work with WEP security, older NIC cards. And I've seen that. And so that's one of the reasons why businesses, if there's 1 or 2% of their users or their clients that are older units that can't connect to this new Wi-Fi security, they're not going to do it. They can't afford to do it. And so inclusion is a lot of reason why, lack of inclusion is a lot of reason why Wi-Fi is not implemented as much as we think it should be. So that's basically the definition: efficient, exportable, optional, self-synchronizing, reasonably strong. It has what's called shared secret keys and must be a minimum of 64 bits in length. The options for creating these keys are 64-bit, 128-bit, and paraphrase. The access point devices can hold up to 4 shared secret keys. And if you've ever used WEP, and we'll look at it Thursday, there's 4 areas to actually type in 4 separate keys. And then you select one that's going to be the default out of those 4. It has 4 radio buttons, and you're allowed to select one of those 4 from the selection. So here we have 4 keys. This one here is selected in your Linksys router as a default. And the access point goes and uses those default. That laptop uses that default, has to use that default key to get in. It can use these other ones, but this is a default one. Oh, refresh, page run 12. There you go. So this laptop over here did not use the default key. This laptop over here did not use the default key. Or this laptop over here used the default. This is the default key it used. This laptop over here used that one. So it's got 4 originally. This is the default one. You have to set a default one, but the laptops can use any of the 4 basically, or the mobile devices, whatever you're connecting to. Here's how the encryption works. You've got basically step 1, the text that the user enters in for those keys, okay, whatever that key is. Then you've got a CRC, which is an algorithm that takes that and basically gives a text file and what's called an ICV file, and takes that and makes a key stream there on step 2, which is a vector plus a secret key plus another algorithm, gives a key stream, and then the leftover XOR is the actual WEP key that travels across the Wi-Fi. That's what's encrypted that travels across. Okay, so for instance, this key here gets encrypted going across the air. Okay, the user types that in their actual laptop for the SSID key, but it's going to be encrypted back and forth across the air here on step 5. And then the reverse happens on the laptop or the mobile device. It comes in and does a reverse logic of all this back from step 5 to step 1 to go back into the router to authenticate that yes, it is indeed that unique key, WEP key. So this here, basically the transmission, as I just mentioned, it goes one way creating, reverse logic receiving. So device authentication is the other way. Wireless LANs cannot limit access to wireless signals by walls or doors, some kinds of data emanation, meaning that we can travel through these walls, we can travel multiple walls. There are ways we'll talk about, though, that you can, we'll look at Thursday even more, you can set the power level of a router to be lesser to where the signal doesn't go as far. You can do that as well. Out of the box, most of your routers are set about a 2 or 3 level. It can actually go all the way up to 8, 9, and 10, and then all the way back down to 1. Sometimes, though, there's issues going beyond 5 on your power level. Your houses aren't made to carry that. A lot of your mobile NIC cards aren't made to recognize it either because the signal is too strong. So here's some authentication types supported by 802.11 standard. Open system and shared key. So on the open system, you've got basically a laptop that sends what's called an associated request frame that says, I need to connect to SSID built. The access point says you're connected, responds with associated response key frame, and then the SSID bill then is pushed out to the laptops. So it's basically sending, it's a beaconing signal basically that is constantly being sent out by the access point to all devices, and those beaconing signals can be turned off on a router, on a Wi-Fi router. Those can be turned off to where they do not signal and beacon that signal to where your laptops recognize them. We'll talk about that here right now. The network's really timing out. Okay. Shared key. Shared key is basically same concept as the one before, except that it takes that key and does an encrypted mechanism to it. It sends a frame like the first one did. This time it has a challenge text, though, that it uses. The challenge text goes through an algorithm key, like a public key, encrypts it, comes back, and says and sees if this original challenge text matches the sent text. If it does, then it's authenticated to the device and it's encrypted. That communication is encrypted. So there are vulnerabilities in everything I've already mentioned in .11, even all the way up through N. Primary, though, is open system authentication, MAC address filtering, and WEP. Now I'll just give you real briefly. MAC address filtering, MACs can be spoofed to be allowed in. WEP can be easily cracked. The open system authentication can be easily cracked as well. Okay? So those three can all be easily cracked in today's technology with what tools we have to work with. Now, the open system authentication is considered weak, as I already mentioned, because authentication is based only on one factor. It just has to match the SSID. Every access point has an SSID. It's manually typed in by the user, or worst case scenario, they buy it at Best Buy and they never change it, and it's Linksys when you drive by, right? Or it's in your apartment building or in your condo building or next door neighbor, and you know they just pulled it out of the box, plugged it in, done. Okay. Unsecure, come on in, free Wi-Fi for everybody. The easiest way to discover SSID is to actually do nothing. Your laptop will recognize it. Okay, NetStumbler is just a program that sends out those beaconing signals faster and aggregates data as it comes in into nice little columns and rows. It tells you SSID, maybe IP address, what security it has. But your beaconing within your laptop does that for you. You can actually look at any beaconing SSID in your laptop when you go home or you leave here tonight. Put your mouse on that SSID. It'll tell you the security level. It'll tell you a lot of times the IP address. Some of your laptops will. It'll also give you the strength of that SSID. All right. Once a wireless device receives a beaconing frame, it can attempt then to join. Some of your laptops will have it set up to where actually it will attempt to join any open network. And I kind of, I'll show you Thursday how to do this, but I would recommend turning that off. You don't want to just connect to any open network automatically, okay? What that means is this. Say you're connected to RVC right now, right? And I set up a rogue network called RVC1. RVC drops, that network drops for whatever reason. Your laptop will look to the very next strongest signal to connect to if it's set up like this, where it's attempting to join in an open network. It'll glom onto RVC1 and say, I don't have any password on there. It's open connection. It connects you to that Wi-Fi connection, and you go on browsing without even knowing it. Happens all the time. The man in the middle we did last Thursday, exactly how that's done a lot of times on Wi-Fi networks. A user goes into a Wi-Fi hotspot, sets up a rogue Wi-Fi hotspot access point with their laptop, changes the name just ever so slightly to what that laptop, to what the normal Wi-Fi SSID is in that room. Like I said, RVC to RVC1. Okay? Most end users, and what they do is actually make the signal stronger in RVC1 than RVC. That's even better, because what happens then is, if it's set up to open system like this for your laptops, it'll drop the RVC and glom onto the RVC1 just because it's stronger. If you've not ever changed your Wi-Fi settings to turn off the open system connection, it does this already. All of your laptops do, unless you physically went in and changed it. It will do this. And so people can be browsing on a Wi-Fi network that still gives them web access, still lets them do all their work, but all the time they could be, their traffic could be being glommed onto and being filtered somehow through programs like we used last week. So that's pretty scary. So we'll show you how to block that from happening on your laptops, and you can educate others too. Open system authentication vulnerabilities continues. It has what's called passive scanning. The most common type of scanning, the wireless device simply listens for a beacon frame for a set period of time, and then it stops. Have you ever seen this happen on your laptop? Maybe you don't have no Wi-Fi connections around, and every once in a while it'll see something pop up on your laptop. It'll say searching, then it'll die. And then another couple minutes later, searching. You wonder why it's doing that or what's causing it to do that. It's this right here. It's passive scanning. It's constantly scanning all the time. And not only is your laptop scanning, but the Wi-Fi routers are scanning as well for devices. So for degree of protection, some wireless security sources encourage users to configure their access points to prevent beaconing from being included in the SSID. So what this means basically is, instead of the user glomming onto the SSID through their laptops, recognizing it, they have to manually type in that SSID. Because if your beaconing's turned off, it's not going to recognize the SSID as being alive on the wireless network. Does that make sense? Problem with that is there's some NIC cards that don't like that. There's some NIC cards and operating systems that do not like the beaconing turned off. You can manually type in the SSID, it'll work for a time, and then it'll drop. It'll work for a time, then it'll drop. Mobile phones are popular for this, all mobile phones basically. Tablet devices, real popular for this happening. And so, yes, you can turn off your beacon, but if you have any mobile or tablet devices at home, more than likely, they're going to have issues with this, or at the workplace, okay? You just have to constantly be typing in that SSID all the time, or connecting to it all the time. So it can be kind of a headache. So a lot of people don't do it because of that. Even though it might be more protection, you can't get any work done. That's kind of meaningless, right? Yes, it's more secure, but guess what? I can't do anything. But it's secure, all right? And so there is some downside to all security. This will be one of them. And when you guys go home tonight, and we'll do this on Thursday, you can actually look at your router, and it has on the first page, a general page generally, an area to turn off your SSID beaconing. You can turn it off altogether. Now, problems arise, as I mentioned already, when it's not beaconing, can affect roaming. That's basically when you're moving from room to room, floor to floor, area to area, and it's that beaconing's turned off. Some of the NIC cards don't like it. Windows XP, definitely big downward spiral on this one. All the way up to Service Pack 2 or 3, the last one, I think was Service Pack 3, still has issues with this roaming being turned off. So it's irregardless of your NIC card, it's the OS for XP. SSID can be easily discovered even when they're not beaconing. It's still transmitting another management frame sent by the access point. So programs like NetStumbler can pick this up, even if it's not beaconing. Okay, and there's other programs too that can pick up these non-beaconing devices. Configuring access point to not allow beaconing to include the SSID provides virtually no protection. Even though it seemingly does, it really doesn't. So here we have a LAN that has multiple access points. Each access point is generally going to have what's called an IP range to connect to those access to those clients. And then those access points can not only connect to those clients, but they can be on separate virtual LANs. They can be on different security. Each one of those access points can be on different security levels. Maybe one on the right, we'll say, is a guest one. When users come into a business, there's an area, this is popular, where they go into a room for, we'll say, a mechanic shop, like say Toyota or something like that. They have this where you can walk in with your laptop and you can connect to their SSID with no password and get in and search the web and things like that. Generally, that access point is going to be connected to just the web, but no file server on that one. Okay, just have port 80 access. That's it. We'll say the one on the left is actually for employees to use. It's connected to maybe a WPA2 enterprise security, and it has access to file servers and things of that nature. And so you can set your multiple access points to do whatever it is you want it to do, whatever purpose you want it to serve in your business. MAC address filtering weaknesses. MAC address are initially exchanged in an unencrypted form in a WLAN. An attacker, and we've already done this, can easily see a MAC address on any network, both wired and wireless. So the NetStumbler will give you the MAC address, by the way, of that IP address, for that access point. So it's easily found, not only the access point IP address, but even those connected to that access point can be found easily as well with NetStumbler. So managing a large number of MAC addresses can pose significant challenges. Some colleges actually tried this when it first came out. students had to register, and then if they wanted to be on the web, on the Wi-Fi, they had to come into IT and turn in their MAC addresses and some other information. I forgot what it was. It wasn't here, but it was another college. Well, it was no time before students began passing around software to bypass that. Basically, they had one MAC address they knew was in the system, and they spoofed MAC addresses easily with software like we've used in here that can be easily done with a novice's knowledge of installing software, basically, and typing in a right MAC address. And so MAC address filtering is not providing means to temporarily allow guests in. That's another downsider. And so if you were to use MAC address filtering in your business, there's no way to have a guest MAC address. It doesn't work. So it's kind of difficult to do that. WEP, I've already mentioned. The only thing I want to talk about on WEP real quick is the strength of WEP is no longer that. It's no longer strong as far as, for security purposes. But again, if your network can only work on WEP, put it on WEP. At least put it on something. It's better than nothing. And when you use a security key, don't use your phone number, your address, your dog's name, your kid's name, your work name, anything you would think people could guess easily. Don't put in the WEP for the WEP password, right? Dictionary words. So something that means absolutely nothing, because that's the first one hackers are going to try. Is your most users that use WEP will use their phone number is the number one WEP key, phone number, number one, the end users use. Number two, part of their address. Number three, kid's name, dog's name, in that order. So number one's phone number, whether the business phone number or their home phone number, that's what hackers try first. They try this before they even try any software. What's the sense in doing software if 9 times out of 10 it's going to be the phone number? Who cares? Just type in this thing phone number, right? And it's not real hard to type in somebody's address in Google Maps and then hover over it. If you have the right Google Maps software, it'll give you not only the address, but a lot of times it'll like filter in like white pages and give you your phone number and things like that. And so those are some rules if you're going to use WEP. But again, it's better than nothing. It is weak. We'll look at that more Thursday and find out more about that. Okay. Now I want to show you. I want to cover one last security, and then I want to show you the video. I want to go to 802.11. WPA2. WPA2, I want to get to that. There we go. WPA2. Wi-Fi Protected Access, WPA2, began in 2004 from the Wi-Fi Alliance. It's the second generation of WPA. It still uses what's called PSK authentication, but instead of TKIP, which was the very first WPA security, it uses an enhanced data encryption. The PSK authentication is basically intended for personal and small offices who do not have advanced server capabilities. PSKs are automatically changed and authenticated between devices after a specified period of time, and they're known as what's called rekey interval. It's kind of a random type of thing that it does. The weaknesses in the PSK is the distribution of sharing a PSK key is performed manually without technology. And so if you are to use the WPA Personal Security, you can put the keys on a USB drive and move them around. And I've had students actually do, like take Notepad and just take your keyboard and just hit it a whole bunch of times and then use that number, character number, alphanumeric character number combination as the key to where it's real hard to, now granted you need the file to bring it to each computer, but it's a single key and it's much more secure to do it that way than to try to guess something. You're not going to be able to guess it. And then with PSK, in order to allow a guest user to have access to this LAN, the key must be given to that guest. And about the only way to do it is actually, again, give me your laptop, I'll put it in for you type of thing. You can do that as well. Second area of PSK vulnerabilities is the use of passphrases, and that's where the notepad comes in. If you use a passphrase with PSK, which a lot of people like to do, make it a truest random as you can with what I just mentioned, hitting your keyboards randomly with your own fingers and thumbs and you know, just your hands basically, and making a random key as easy as possible. There are websites too that you can go to that allow you to type in how long you want a password to be, and it'll give you a pretty good strong password. PSK is a 64-bit hexadecimal number, the most common way in which this number is generated by entering a passphrase, consisting of letters, numbers, punctuations, etc. That's between 8 and 63 characters in length. PSK passphrases of fewer than 20 characters can be subject to a specific type of attack and broken. Over 20, though, it's going to be very difficult to break. And it has what's called an AES CCMP encryption, which basically is one of the highest encryptions when it comes to WPA2 for personal security. And it's based upon the algorithm, AES algorithm, that's one of the newest algorithms for encryption, and fairly secure. Fairly secure. It does all randomization of keys. Kind of what I was talking about the military that they're working on, but not as secure as what the military is working on. But that's what they started with, was the AES security encryption. So let's look at this here, because we didn't cover all the WPA, but because I want to watch the video. WPA Personal Security uses the security mechanism for this one is PSK, Authentication. Security level is low, medium level, depends on the length of your passphrase. Again, using a longer passphrase, the better. WPA Personal Security encryption uses TKIP, medium security. WPA2 Personal Security authentication uses PSK, medium security, and the encryption on this is AES CCMP, very high security. Lastly, enterprise level. And you have to have for enterprise level for WPA2 a server to do this on. When we first set up WPA2 Enterprise here on campus, it was like a 4-page document to set it up for each user. So there wasn't many users that tried it. Okay, now it's down fairly simple. You log in with your username, password. It does everything else for you within a browser environment. But the enterprise level is definitely the most secure. And two main weaknesses though for this one. For enterprise, I'm going to stop on that one. Enterprise is basically the convoluted, well, it started out convoluted steps to implement it, but now they've actually got it pretty much to where it's fairly automated. It's tied into your LDAP authentication on your server. So most of your networks have like Windows authentication on their network, and they're using LDAP to log into their clients, whether it be Mac, PC, or Linux. This new enterprise wireless security with WPA2 works real well because all you're prompted with now is a username, password, and if your NIC card can handle it, it actually does all of the setup for the end user and remembers that in cache for like 24 hours. After 24 hours, you have to re-authenticate again with another same username and password basically, but that's all you're having to do. Before you were having to like right-click on the SSID, apply the right security, whether it be AES or TKIP, then you had to go in and say, okay, am I going to do this here at work or am I going to do it outside work? And then you had to type in a password for the password server key, and then you had to type in a password for your network account, and then you had to save everything. It was totally crazy. Now, I did it because I wanted to do it, but most users looked at that document and goes, is there a fireplace somewhere? Can I put this in? Because I'm not doing this. I'll go back to paper and pencil. I don't care. But, you know, they did have the less secure Rock Valley College one still out there. But yeah, they've made it much more easier. And that's with everything technology. When it first comes out, it's going to be the most difficult thing for people to do. The beta stage is going to be the most difficult thing. But it gets better and easier as people use it and the technology gets more efficient. So, okay, let's watch this video real quick on wireless and wireless security. Make sure this one works here. I'll try it anyway before class. We'll see here. I'm going to let it cache here real quick. I'm going to go all the way to the right before I start playing this. I like downloading these, but I didn't, so we'll let it go all the way to the right. There we go. Guess I'm not getting sound. Let me unplug this. There we go. Back to the left. Okay. Let's copy it here, and I'll go over to Mac and see if it works there. If it doesn't work here, we'll just read the words. Hopefully it will. Okay, it's not working. I'm going to read it. Maybe that's why it has captions in it. Okay. Guy's waiting at the airport. He sees a guest account. Yeah. Unsecure. He says yes. Let's do it. I got to check my email. Amateur hacker comes in. Hope somebody connects to that unsecure network. Now he's capturing Jackson's email. So, already mentioned that, but this does happen a lot. It does have in here the script down below, I think. But yeah, this happens quite a bit, believe it or not, in networks where people do just that. They set up a Wi-Fi network, Wi-Fi access point, like within the Mac, super easy, and Windows too. Well, I'll show you real quick, like in the Macintosh, how easy it is to create a Wi-Fi network or a rogue network. Let's take this, create network, and I'll do like ATT, put the channel I want it to be, click OK, and now if anybody has Wi-Fi, you can actually see AT&T show up on your phone. Now, you're not going to have any net connectivity or anything. I don't have that connected to it. But you should be able to see AT&T and connect to it with no password. Does anybody want to try that real quick?
Yeah, connected.
Connected? Yep. And see, there's no connect. Now, what you could do is, what they do is they basically take, there's apps that actually allow you to do redirects to where when they connect to your access point, it actually puts up a bogus spoofed page that looks like a, kind of a security page of some type, say, hey, you're accessing this free Wi-Fi, please click I agree. They click I agree, it installs a keylogger and some other applications, and then you're going to town doing man in the middle basically while they're searching the web. And so, and those keyloggers can do screen scrapes, send it to your computer where you really don't have to do a man in the middle. It does it for you. These programs do it for you. And so there are prepackaged script kiddies that actually allow you to do like a bogus fake AT&T page, kind of security page that the users use in cafes. And you saw how quick it was for me to set up that on a Mac. Windows 7, Vista and 7 both allow you to do that as well if you have a Wi-Fi card on your laptop, which most of you do. You can easily create a network just like I did, give it a channel. You can even get a certain encryption if you wanted to, or no encryption, just let people in. You can also tell it where to redirect whenever they come in to a certain web page location. So if you're running like XAMPP like we did last Thursday, have them go to a certain location on your computer that has that authentication page with that, just a simple web page for them to click on, a button that says I agree. You can even have them put in, which most people will because it's free, say to get this you have to put in, I don't know, an email address. And what's really scary is, and I can mention this, how easily people will put in stuff like their credit card information and things like that, even if it says on there, oh, you won't be charged, but we need your credit card information for validation to make sure that you're over 18 or some bogus information like that. All right? It's amazing how many people do that. And so, you can see like within a day's time, hackers are glomming onto, if you're in the right area, Chicago, Schaumburg, even Rockford, that's a lot of people connecting to Wi-Fi. You can get a lot of information easily. And that's where identity's stolen, things of that nature. So I always tell people, if it's free, it's not free. Okay? I guarantee you there's something going on 9 times out of 10. And I'd rather be wrong and not, I'd rather be wrong and say that maybe there's nothing going on, but I'll be safe to be wrong. I'd rather be wrong and be safe than maybe that one time connect to something. And generally it's not going to be, generally the red flag for sure is, and a lot of hackers do this, they'll put the word free in there, in the Wi-Fi name, in the WP, the SSID name. That's a big red flag. You know that for sure is something really dangerous to connect to. Because free, they think most of the time people's going to see the word free, and most of them are right. Some people like you guys hopefully will see the word free and go, that's a big red flag, the word free in, the SSID name. That's a big one. But on Thursday when we do the web lab, I'll actually give you a handout on some more kind of safety precautions that you guys can use when you go to Wi-Fi access points, and also can give others. One of them being what I just mentioned. The one I just set up actually is a peer-to-peer. It's a peer-to-peer access point. But most end users aren't going to know what that is. What's the difference between a peer-to-peer and a non-peer-to-peer access point? It all looks the same to them. It's SSID, but it'll actually tell you in Windows if it is a peer-to-peer network when you connect to it. But you have to look for it before you connect. So, any questions on Wi-Fi? Okay, so you'll bring your laptops on Thursday. I know you guys are most all here on time. We start right on Thursday. I'm going to have the Wi-Fi router up and going and running. I'm going to get here a little early to get it up and going. And then what we'll do is we'll do a web lab where we will, in fact, I'll have you guys bring in some passwords for me. Who wants to bring in a very difficult, let's do 13 characters, alphanumeric symbol. Anybody want to do that? A 13 character one. Anybody want to bring one in on Thursday? Well, I'm going to have you, I'm going to have you basically email it to me. Just email it to me between now and Thursday. That's fine. Okay. Medium-sized password, do like a 6-character password. Just character number, alpha number. Anybody want to do that? You want to volunteer to do that? Email that to me between now and Thursday. Okay. And then a symbol password, a password that is either something that is, whether it be your dog's name, something to do with your address, some name in your family. Somebody want to do that? Yep. Okay. And email it to me by Thursday. And I'll have all 3 of those ready for the lab on Thursday, and we can get going on it. And that's it. So bring your laptops. Raise your hand who's going to bring laptops again so I can kind of know real quick. Okay, great. What about 8 laptops? Great. Cool. Well, I look forward to it.
Can I just use this one as a super long one? It'll take forever at all.
Yeah, can you email that to me?
Yeah. I
Email me
mean,
that.
we can just put in a special character, whatever, but it's 32 characters.
You can email me my Gmail account from there if you want.
Okay.
That would be easier for you, right?
Yeah.
It's a cconkle at Gmail. Yeah. It'd be easier to do that than going through Eagle or something probably.